Hello class, today we are going to start with equations of proportional relationships. So everyone's book should be on page number 41. If you are not on page 41, let's pause the video until everyone is there. Okay, now that we're ready, we're going to start by reading the I can statement. So read along with me. I can write equations to represent proportional relationships and identify the constant of proportionality in the equation representing a proportional relationship. So please notice the key word here is equations. We have already talked about tables and graphs. Today we're going to be talking about equations and how can we tell when they are proportional. We're also going to be talking about the constant of proportionality, or the letter K, just like we did with tables and graphs. Please look at the bottom of the page. At the bottom of the page, it says, two quantities are proportional if the ratios comparing them are equivalent. And that is something that we have been talking about over the last few classes, that when the ratios are the same, then we have a proportional relationship. That ratio is that constant of proportionality. Remember, the constant of proportionality is always y over x. Y over x. Well, today we're going to find that the equation to represent this picture of proportionality, whether it be a graph or the situation, is always going to be y equals kx. So if this is my equation, when we have a proportional relationship, please notice it's y equals k, the constant of proportionality, times x. So if I look at this first example, it says y equals 3x. So the actual k, I just look right here in front of the x, is going to be 3. We've already done this when we've looked at a graph. When we looked at a graph before, this graph is proportional because it goes through 0, 0, and it is straight. Remember, one way that we looked at a graph is we said, oh yeah, we have to know what is the unit rate. So if I look at the 1 and I go up to the line, and then I look over at the y, or y over x, this is going to be 3. So my y over x is 3 over 1 when I look at the graph, which matches the 3 in the equation. So this may sound a little confusing, but as we do more examples, hopefully this is going to make more sense. So let's go ahead and go to the next page, turn to the next page, and look at example 1. On example 1, it says that Olivia brought 6 containers of yogurt. She bought 6 containers of yogurt for $7.68. The equation y equals 1.28x can be used to represent this situation, where y represents the total cost of the yogurt and x represents the number of containers bought. Looking at the equation, it says identify the constant of proportionality, or the k, then explain what it means. So first part is just identifying it. Remember, we're looking at y equals kx. We have the one given to us, which is y equals 1.28x. So think about what would be the k. It's actually just going to be the number in front of the x. So my k is 1.28. And you may be wondering, well, how did they come up with 1.28? Why is it 1.28? Okay, well, let's go back to thinking about what k is. It's y over x. In this case, y represents the total cost. So let's write cost next to the y. X represents the number of containers. So this would be containers. So it's cost per container. If I now look at the problem, look at the first part of the problem, sentence 1. Olivia bought 6 containers. That would be in the denominator. And it cost $7.68. So pick up your calculator, please, and go ahead and divide 7.68 by 6. and you will find that you get 1.28. Well, what does that actually mean when we get to the explain? Explain what it means. It means not just 1.28, it means $1.28 for every one container. It is our unit rate. So that is the explanation that we're looking for. So you can write it in here. Again, the constant of proportionality means the cost of each container of yogurt is $1.28. So the constant of proportionality is 1.28, and the unit rate with a label is $1.28 per container. All right, go to the next check. Now we're going to look at a situation. An airplane travels 780 miles in 4 hours. The equation is y equals 195x, models the situation. What is the constant of proportionality? Everyone write down what you think the constant of proportionality is. Remember, we're thinking of the equation y equals kx. Hopefully you wrote down 195. Good job. Give yourself a smiley face if you did. Since we know it's 195, you may be wondering, okay, I see it in the equation. Where did it come from? Well, look back at the situation. An airplane travels 780 miles in 4 hours. Remember, K is also a unit rate. That's 780 miles in 4 hours. How much is that in 1 hour? So go ahead and divide on your calculator or in your head. You should have gotten 195 miles in 1 hour. So if I read these situations, let's look. The first one says an airplane travels 390 miles per hour. That is not the same as 195 miles per hour, so that is not correct. An airplane travels 1 mile per 4 hours. Think about that. Does that even make sense at all? If an airplane travels 1 mile in an airplane, and it takes 4 hours, seems to be a problem with the airplane. That does not make sense. An airplane travels 1 mile per 585 hours. That's even worse. That definitely doesn't make sense. Can you imagine going anywhere 1 mile away and it take you 585 hours? It's nonsense. Then finally, an airplane travels 195 miles per hour. That we know is the correct answer. Be careful though, because when we start looking in math class, a lot of times we just look for the number and we don't really read. And that is a problem. If they had said travels 195 hours and goes 1 mile, that still has the 195, but that does not make sense. So that would be a big no. Okay, that's not right. So be careful that you're actually reading the labels, you're actually thinking about if it makes sense in the context of the problem. For example, an airplane we know is fast, so it makes sense that it's going 195 miles per hour. Okay, go ahead and go to the next page, and let's take a look at how we came up with these equations. So when I know this is the equation I want, this is the equation that I have been telling you many times. We've been saying K equals Y over X. So the question is, how do we get from here to here? If we think about it, if I were to give you a problem like 10 equals K times 2, think about how I would solve that. If I'm solving for K in a normal equation, I would just divide by 2, divide by 2. 2 divided by 2 would be 1. And so I would have K equals 10 over 2. Now, instead of using 10 and 2, let's use our Y and our X. So I still want to solve for K. Notice that we're dividing by X. This X just represents a number. So if I divide by X on both sides, that will cancel out and become a 1. And so now I have K equals Y over X. So that is how these two are related. It is actually equivalent equations. They are the same equation, just written in two different forms. Okay, go to the bottom of that page. We're on page 43 right now. Go to the bottom of page 43. Ready to do the next problem. A mechanic charges $270 for 5 hours of work on a car. Write an equation that compares the total cost to the number of hours he works on a car if it is a proportional relationship. So we need to first make a unit rate or find the K. In this case, it would be money per hour, 270 for 5 hours. Go ahead and do that on your calculator right now and write down what you think the K is. The K should be, 54. That, of course, means $54 for every 1 hour that he works on your car. But that's not the question they asked. They actually said, what is the equation? So an equation has to look like this, y equals kx. But instead of the K, the letter K, we want to put the number that is the K. In this case, we're going to put the 54 in there. So the final answer is going to be y equals 54x. So that is the whole answer. You do not want to just write 54. You don't want to write y equals kx. You want to write y equals 54x. Now, we can use this equation to find other information. For example, we may say, well, I have a car issue, but I know it's not as bad. It's only going to take the mechanic 2 hours. So how much money do I need to pay for 2 hours? Well, thinking of y, change colors here, y over x, hours is for x. So if I said 2 hours, how much money? I would take the 2 and put it in for x. So now I'd have y equals 54 times 2, and I can solve that to figure out how much money I would pay. 54 times 2, $108 for 2 hours of work. All right, I could do the same thing if I said 10 hours. I would take 54 times 10. Or if I said 20 hours, 54 times 20, and so on. Okay, we're going to move ahead to page 44. This is the last problem we're going to do in our book, so please hang in there with me. Let's read the last one. Jack is in charge of the 120,000-gallon community swimming pool. Each spring, he drains the pool in order to clean it. When finished, he refills the pool with fresh water. Jack can fill the pool with 500 gallons of water in 5 minutes. Write an equation that represents the relationship between the total number of gallons, y, and the number of minutes spent filling the pool, x. So x was minutes. To start this problem, we are going to start by finding the K. To find the K, we're going to go y over x. I like to start by matching up the words to the y and the x, so I know what the labels are and which numbers go in the numerator and denominator. So y is gallons. I read that right here. And x represents minutes, so gallons per minute. Now go back to the original problem and look here. Jack can fill the pool 500 gallons of water in 5 minutes. So I'm going to go 500 gallons for 5 minutes. Let's solve that by dividing. So that means that K equals 100. Let's write the equation. You're going to take the 100 and you're going to put it into y equals kx. So my final answer for the equation part is y equals 100x. Y equals 100x. Part 2 of the equation says, how long will it take to be completely filled? Let's go back up to the top of the problem. To fill it, we need to know, well, how many gallons is the pool? I see it's a 120,000 gallon pool. Remember, which one is gallons? Y is gallons. So if I have y equals 100x, and I know y is gallons, I'm going to put the gallons where the y is. So 120,000 equals 100x. We're going to solve for x by dividing by 100. Divide by 100. These will cancel and give me 1. So x would equal 120,000 divided by 100. Do that on your calculator. And we get 1,200. What? Well, let's look. X represents minutes. So 1,200 minutes. Did anybody wonder, well, how many hours is that? If you know there are 60 minutes in an hour, if I divide by 60, I would find out that that is 20 hours. And some of you maybe already found that out. Okay, next you're going to be doing a worksheet to practice. You're going to go through a couple examples together, and then you're going to be working at your tables on the rest of the worksheet. I would like you to complete the entire worksheet today. We will be coming back. I'll have another video in a moment about our final part of putting it all together, and we'll do a foldable. All right, go for it.